We observed that in all their reactions, the only ones that formed a precipitate were sodium carbonate with barium nitrate, as well as sodium carbonate with barium chloride. These are the following reactions for the precipitates that were formed. Barium is non-soluble with carbonate, therefore a precipitate formed. These are the following reactions for the rest of the stuff.
23 more minutes. 13 more minutes.
All of which are soluble in a solution. Therefore, we observed that the only one that formed a precipitate were barium carbonate in the product. In the second set, we observed that when barium reacts with sulfate, precipitate forms. Therefore, barium is not soluble in sulfate. We also observed that when strontium reacts with sulfate, it forms a precipitate as well. In the other following reactions, no precipitates form, meaning that both solutions were soluble. These are the following reactions for barium nitrate with
take your last
sodium
observation.
sulfate, where
Class,
barium
take your last
sulfate
observation. We'll
is
continue on Thursday.
and
Put
forms a
your
precipitate.
solutions back, put it back in the bag. Rinse your glassware off.
In our discussion, we will be discussing the following factors that determine if a precipitate forms or not. In the first equation, we have barium nitrate, which reacts with potassium chloride. The products are barium chloride and potassium nitrate, both of which are soluble in each other. So therefore, a precipitate does not form. In the second reaction, barium chloride reacts with sodium nitrate, and the products are barium nitrate and sodium chloride, both of which are soluble in each other. All alkali ions such as sodium and potassium are soluble in all solutions. Nitrate is soluble with all positive ions. Therefore, a precipitate didn't form in this reaction. In the third reaction, we have sodium carbonate, which reacts with potassium chloride. The products are sodium chloride and potassium carbonate. Since all alkali ions are soluble in all solutions, a precipitate didn't form. In the fourth reaction, barium chloride reacts with potassium chloride, and the products are barium chloride and potassium chloride, both of which are soluble, and since they were in the reactants, we already determined they were soluble without looking in our Hebden.
In this reaction, sodium nitrate reacts with potassium chloride, and the products are sodium chloride and potassium nitrate, both of which are soluble because they are alkali ions, and as well, nitrate is soluble with all positive ions. Therefore, a precipitate didn't form. Following reaction, sodium nitrate reacts with barium nitrate, in which barium nitrate and sodium nitrate are the products. Therefore, the reaction didn't occur. Sodium nitrate reacts with sodium carbonate, which the products are sodium nitrate and sodium carbonate. If they were in an aqueous solution in our reactant and are soluble in our products as well, therefore a precipitate didn't form. As well, they are both alkali ions and are soluble with all the negatively charged ions.
In this following reaction, sodium carbonate reacts with barium nitrate. The products are sodium nitrate and barium carbonate. Barium is not soluble with carbonate, therefore a precipitate does not form. In this reaction, sodium carbonate reacts with barium chloride, and the products are barium carbonate and sodium chloride. A same product was formed as in the previous reaction with barium carbonate, so a precipitate does not form. In this reaction, barium chloride reacts with barium nitrate. which forms barium nitrate and barium chloride, both of which are soluble in each other, so a precipitate does not form.
Step 2 of our experiment, barium nitrate reacted with sodium sulfate, and the products were barium sulfate and sodium nitrate. We observed that barium sulfate formed a precipitate, which therefore means that barium is insoluble in sulfate. In the next following reaction, barium nitrate reacts with aluminum sulfate and forms barium sulfate and aluminum nitrate. Barium is then once again not soluble with sulfate. The next reaction, strontium nitrate reacts with barium nitrate and forms strontium nitrate and barium nitrate. We determined that both of them are soluble because they were formed in an aqueous solution in the reactants. Therefore, they had to form an aqueous solution in the products. As well,
Yes.
nitrate is soluble in all positive ions. Barium nitrate reacts with barium chloride. The products are barium chloride and barium nitrate once again. Therefore, they are both soluble in each solution. Next reaction, precipitate forms because barium chloride reacts with sodium sulfate and forms barium sulfate and sodium chloride. Barium sulfate is once again a precipitate, as it was in the first two reactions that a precipitate formed. This is because barium is insoluble in sulfate solution. Next equation, barium chloride reacts with aluminum sulfate and forms barium sulfate once again and aluminum chloride. Barium sulfate is not soluble together, but aluminum is soluble in chloride. So the next equation, barium chloride reacts with strontium nitrate and forms strontium chloride and barium nitrate. Nitrate is soluble in all positive ions, and strontium and chloride are soluble. Therefore, a precipitate didn't form. The next equation, strontium nitrate reacts with sodium sulfate and forms strontium sulfate and sodium nitrate. Sodium is one of the alkyl ions that are soluble in all solutions, as well as nitrate is soluble in all solutions. Therefore, a precipitate didn't form. But strontium and sulfate aren't soluble, therefore a precipitate formed. Strontium nitrate reacts with sodium sulfate, and the products are strontium sulfate and aluminum nitrate. Nitrate is soluble in all positive solutions, as I explained before, and strontium and sulfate aren't soluble, which is a precipitate that was formed in the previous reaction as well. In the last reaction, aluminum sulfate and sodium sulfate are reacted together to form sodium sulfate and aluminum sulfate, both of which are soluble in the sulfate solution. Therefore, a precipitate didn't form. All equations reached equilibrium. Therefore, the rate of crystallization equals the rate of dissolving in all the precipitate equations. As well, that they occur, and therefore there are no macroscopic changes that are visible. Our equations were made off the solubility chart, where we figured out if each solution were soluble with each other. An example, barium carbonate isn't soluble because the H plus ion and NaH4 are soluble, or only ions that are soluble with carbonate. Therefore, barium wasn't soluble with carbonate. Therefore, a precipitate formed. And as well, strontium and sulfate are low solubility. Therefore, a precipitate formed. This concludes Ardemon Jaswal's and Monica Dial's discussion on solubility. Thank you.